there, this is Katie Kimberling with TutorPUG, and I wanted to do a series of short videos on the antiderivative concept and technique called U-Substitution. I'm going to break this down into 3 separate videos so that they're short, and also if you feel like you have a good grasp of some of the beginning and initial things, you can go ahead and skip to the other ones. So the plan that I'm going to follow is the first video, which is this one, is I'm going to do an introduction to U-Substitution, and I'm going to do a couple of super easy ones where I show you some problems where we already know what to select for U and DU. And then we'll move in the part 2 video will be what I would consider medium level difficulty, maybe a quiz level difficulty. And then I'll do a third video labeled as such that I will call a test level difficulty. We'll consider those pretty difficult. So I want to do a quick introduction to U-Substitution and what it is, and then I'm going to walk you through at least one problem, maybe 2, where I make it really easy and I do the first 2 steps for you. So the whole idea for U-Substitution is that you're being given a problem that you have to antiderive, and one of 2 things is happening. First of all, it does not immediately follow one of your antiderivative rules. I can antiderive a 4x, and I can antiderive a very simple e raised to an x without a power on it, but I can't antiderive an e with raised to something with a power squared or something higher, and I also don't have product rule for antiderivatives. So I'm stuck, I can't antiderive it as is, and it won't simplify algebraically into one of those antiderivative rules. So what I have to do here is U-Substitution. I have to temporarily, using U and some substituting, rewrite this into the form, an equivalent statement that is the form of an antiderivative I do have a rule for. So one thing you might want to do right now is go back and refresh your antiderivative rules and your derivative rules, because this type of problem uses both at the same time. Deriving is one teeny tiny little piece, it's step 2. You're doing that in order to overall antiderive. Also, I'm going to put a link to some handouts in the show notes of this, so hopefully that might take care of some additional questions that you have. So the first thing we have to do is, from this where we have a 4x and e to the 2x squared and a dx, every single piece of this problem that has the letter x in it is going to be translated into an equivalent u portion. So we have to identify what u is going to be, and there's only one answer. Then once we get u equals what it's equal to, we'll derive both sides of that equation, deriving. Then we'll do our substitution. Then we'll actually antiderive that substituted version with the letter u in it. And our final step is going to be to resubstitute back into the original language the problem was presented in. So for this problem, I'm going to go ahead and show you that. I'm going to show you steps 1 and 2. So in this case, u is going to be equal just to the exponent on e, and du, the derivative of u is du, the derivative of 2x squared is 4x, and we have to put a dx, which means with respect to x. So I'm doing steps 1 and 2 for you. I've got step 1, which is the exponent on e, and I've got step 2, I derive u, it becomes du. 2x squared derives to 4x, and you must have dx, which means with respect to x. So I've done steps 1 and 2. So on this problem, you're going to jump in and just translate or substitute all of these components into their equivalent statements using this as your translation dictionary. So what I can say is this antiderivative is equivalent to an antiderivative translated into a different language. This piece, e raised to the 2x squared, and if you'll recall, I have a rule for antideriving an e to the x, or an e to the k, or an e to the p. So this piece right here can be rewritten as e to the u, because I let that be equal to u. So this piece right here becomes e to the u. I've got that taken care of. I still have to translate or account for the other pieces of the original problem. So I still have to translate a 4x dx, all being multiplied together. So I come down to this line of my translation dictionary and I say, oh look, 4, an x, a dx, all of that translates into du. So this becomes the antiderivative of e to the u du. And I have an antiderivative rule for something nice and simple like that. Step 4 says I'm going to antiderive it. Well, the antiderivative of e to the u is e to the u. And our integrand is naked. It doesn't have any numbers on the top and the bottom. So we have to give it closed. We're back to adding c to it. This is my step 3. This is my step 4. And my step 5 is now going to be, this is in the language of u, but my original problem was in the language of x. So I have to re-substitute back in. U is really, according to my cheat sheet, 2x squared. So that would be my final answer. That would be my final answer, but I need to show all these steps for how I got there. Here's one little quick, neat tip about U-substitution. Sort of a good news, bad news. The good news is you should never get these wrong because the ability to check your answer is built into the problem. The bad news is we're lazy and we don't want to check it, and sometimes it takes a little bit of time. But if you think about our calculus ladder, if we start at some equation and we antiderive it, that is the activity of going up our little calculus mental ladder. Antideriving is going up. And that would give me this answer. Well, if I started on that rung, my answer, and I derived it, which is the going down the calculus ladder, I should get back to my equation. So once you do your U-substitution problem, if you take the derivative of this, if you get back to where you started, you've done it correctly. Let's try it. The derivative of e to the blah is, if I derive this, I recopy, I get e to the blah times the derivative of the blah. Well, the derivative of 2x squared is 4x, and that is what I started with. It's written in a slightly different order, but that doesn't matter. So this is a correct answer. It's a 100% correct answer. Let's try another one where I still show you what u and du should be. Here's our second example. I have the antiderivative 8x squared plus 42 quantity raised to the 76th power times 16x with a dx. And remember, the squiggle, the integrand at the beginning, and the d letter at the end are combining to issue a mathematical command which says antiderive what's sandwiched in between. When I get to this step and I actually antiderive it, both of those disappear because I have executed the command. So on this problem, I have actually two options. I could write this statement 76 times And then I could FOIL it all out and multiply it all out and then distribute 16x, and sometime on the middle of next Tuesday when I'm done with that, I could come back and I could anti-derive every single individual term. Well, I don't have time for that. So I'm going to use U-substitution. We're going to have U be equal to just the guts of the chunk with the bigger exponent. And then when I derive that, the derivative of 1u is 1 with respect to u. And the derivative of 8x squared is 16x. The 42 goes away. And we tack on the dx. So there's your step 1 and 2. Now when we're ready to do step 3 and translate or substitute this into his equivalent meaning antiderivative, but in a different language, the language of u, make sure you have an equal sign because you're saying this equals, well, this piece can be rewritten as u. That piece was being raised to the 76th power, so my u is going to be raised to the 76th power. And then the leftover part, 16x dx, all of it has to translate. This tells me how it translates. Okay, 16x dx translates into du. And that is a variable raised to a number. I have a rule for that. If you're anti-deriving x to the n, it becomes, you take the exponent, you add 1 to it, you divide by the new number, poof, you're done. So step 4 is going to be, I'm ready to anti-derive, so those two commanders are going to go away as soon as I apply the antiderivative rule to this. That becomes u to the 77th over 77 plus c, and then my final answer will be what u actually is holding the place for. There's my final answer. If I derive it to check myself, I would have to use the chain rule. This is the part where I said we get lazy and there's sometimes we don't want to do the derivative, but we can. If I did the chain rule, the insides would stay the same while the outside drops and flops. So that would leave me 77 8x squared plus 42 to the 76 times the derivative of the inside, and those pieces cancel, and that gets me back where I started, so I did it correctly. The only way to get U-substitution and be confident in it is to practice. You have to practice multiple times over and over so you can begin to recognize what is U? How do I substitute? Do I even need to use U-substitution? So if you're ready for part 2, you can stop this video, maybe look at some of the links in the show notes, and go to the next video, part 2, which will be some slightly more difficult U-substitutions, and also recognizing when you have to use U-sub and when you could use algebra instead. Happy mathing. This has been Katie with TutorPUG. Thank you.